We'll proceed in vector field line integration. Vector field line integration. Vector field line integration. What we have talked till now is if I have a kind of if I have a vector field, so vector field is nothing but it is a function which generates a vector. If I have algebraic equation, then algebraic equation has independent component x and y, then it is considered as function over x and y, where function over x and y returns a value, a number. If I have a vector field, if I have a function small f over x comma y, then it returns a value based upon x and y. If I have a vector field, that vector field with independent component x and y, if I pass x and y, then it returns a vector. This is what we have discussed. So, algebraic function returns a value based upon the independent component that is passed to the function as parameter. Whereas the vector field is also a function capital F top one arrow and then x comma y in the braces. The function is written. So the vector field is also a function where x comma y parameter is passed, then it returns a vector. So that is a vector field. Now we have given as an exercise that if I have a vector field xi plus yj and there is a circle and circle has four quadrants and circle is centered at origin. In the first quadrant where x and y axes are positive and it is with radius 1, if it is with radius 1, and then what is the line integral of vector field with the first quadrant of the circle. So line integral of the vector means what is the vector field. Okay, vector field generates vector, then that vector dot product of the line I am talking about and then integral. In other words, if I have a vector field capital F, suppose vector field is a force, vector field is a force, and then line integral means I have a force and then I have a path. This is what we have shown. So if I have an object can move only along this path. Like on a table, something is kept. That item can move only along the table. If it moves only along the table in one axis, that is I axis, then if I apply force on that object, force can be from any angle. It can be 0 degree or it can tilt the angle. But rather than showing it as an angle, I can just say a vector. So if force is from a vector and it is applied on the object, then vectors, the effective force that vector would receive, vector has to move only in x direction. It cannot go up, down and this direction. This vector can move only in x direction. If vector can move only in x direction, then if there is a force applied on the object, then effective force in x axis, the force the effective force along the x-axis, okay, effective force along the x-axis is force dot product with the x-axis or force cos theta. If force dot product with the x-axis is the effective force along the x-axis, then I have to multiply by the distance. So if this item has moved x meter and effective force, if this force vector is F, then effective force is Fx, then Fx into x is work, is the energy it receives from the force. So if the force vector has two components, x and y. Force is a vector and it has two components, x and y. The magnitude of the force is fx square plus fy square square root. So magnitude is high, but the effective force along x-axis. Okay, if this is the force, then effective force along x-axis is its x component. So fx into distance. So fx is less than fx square plus fy square square. So the actual energy work done, actual energy this object is receiving when it is moving x meter is fx, x component of vector field into x, that much only. If force is along this axis and then how much it is receiving, then full f it is receiving. If force is along, or if object has to move along this direction and force is along this direction and it has x component and y component, but they are in same direction, then if it moves x meter, then energy receives from its force is x square plus fx square plus fy square square, where fx is x component of f and fy is y component of the vector field f, vector f. But if so, what we have to do, whatever the vector field I have, dot product with the direction of the movement. Okay, that will give the effective force along the x-axis. If I have effective force along the x-axis, then that force into the distance. Okay, so I can say if the mass has to move in the unit vector I, then F dot I, whatever comes, is the effective force along the IS into the displacement. Or I can say if displacement is x, then the line vector is xi, strength is x, and I is the direction. If this is f, then f vector dot xi, or if it is a line vector, if I call it, okay, right now this much. So fxi, x component of f, fxi dot xi, fxi dot xi is called line vector. Line vector in a sense that if I multiply force into displacement, that much is the energy imparted on the displacement. But force has to be in direction of the displacement. If that is true, then f dot xi. If this is the displacement direction, if r is equation of the line, r is not vector. If r is the equation of the line, then dr is the vector. Dr is the vector. We will talk many things out here. Okay. So what we have discussed by now, if if this is if this is I vector x axis and this is force, okay, if this is x axis and this is force, then force dot x unit vector, that is now effective force along x axis, multiplied by the distance it is traveling. Okay, so if it is traveling x unit along x axis, and if this is the force, then x component of the force, this is fx, and then fx moving along fx into x is the called line integral. Line integral means multiplication of the vector field with the displacement it moves. Since it makes angle, then along the movement, I won't say x-axis. If this is the movement direction and this is the force, this is x-axis, then if this is the movement direction, then this force, its component along this direction, then now effective force is this much, then multiplied by the distance. So f dot unit vector along this direction, then it comes like this, then multiplication. So suppose the direction is u, then the magnitude of the u, then u vector divided by magnitude of the u, that is the unit vector. U vector divided by magnitude of u dot with F. If I do, then F effective force in direction of u comes into the picture. Now then multiplied by the magnitude of u. U vector divided by magnitude of u. U vector divided by magnitude of u gives me unit vector. That unit vector dot with this force vector gives me effective force in the direction of unit vector u, unit vector of u, then multiplied by the distance it has covered, then that is again multiplied by magnitude of u. So magnitude of u cut down, then actual the energy, this object that moving in this direction is nothing but force dot product with the u. Okay, so if I say that if I want to calculate whatever comes as force and then u vector, if I do the if I want to do the multiplication, okay, so the idea is I want to do the multiplication. I have I have x-axis. I have x-axis, and there is a velocity vector called Vx. Vx is a algebraic equation. So Vx is a graph. Vx is a algebraic equation, a function over x. This is a velocity vector. Velocity algebraic equation. If I have Vx, okay, so if I have Vx equation, then how much displacement it makes, okay, so a person has a velocity Vx, and then this x is time, this x is time, and this is function over time. Now if I want to calculate the net distance it has covered till time something like capital T, till time capital T. Then I have to integrate, I have to calculate the area underneath the function. So if I have a function, if I have a function f t, fx, where x is axis is time. So I have a function vx, that is velocity function. So if I have a function vx, if I have a function vx, then vx is velocity vector. Then if it is a graph, if I calculate the area of that graph against this x-axis, that area is the net kilometer that is traveled. Now for that I have to do integration. This is what integration we have talked thoroughly. So Vx dx integrate from the lower limit to higher limit. If lower limit is 0, starts from origin, then it is not required, then up till the higher limit. If higher limit, now it is capital T. So if this is x-axis and x-axis denotes time, and I have a graph equation Vx, that is velocity vector, then at any time capital T, how much distance it has traveled. That is the area of the graph. Area of the graph means more or less Vx multiplied by x, means that is the area, vertical into horizontal, vertical into horizontal. Vx multiplied by horizontal, if that is the area, then by integration I have to calculate Vx dx. Ds is just symbolic, and then beginning point to end point. So beginning point is 0, then 0, and end point, then end point is capital T. Okay, so end point is capital T. If end point is capital T, then integration from 0 to T. Okay, integration from 0 to capital T Vx dx. Okay, now I have now there is a unit vector, there is a vector u. Now If there is a vector I, if there is a vector I, means along x-axis, I want the line integral. There, I calculated the time integral. If I multiplied Vx, if I did Vx dt, Vx dx, Vx dx, and x I took from lower limit to higher limit, that area I am calculating, so that net kilometer travel, then I can call, if independent variable is time, then that is time integral, or it is a line integral. This is line integral. Line integral means whatever we have the algebraic equation, then that algebraic equation I have to do integration along an axis, and then lower limit, higher limit, I have to set how much area I want to calculate. That is the way integration works. If I want one area to be calculated, then integration of that curve along this axis and lower limit and higher limit we put. Now, if I have a force vector, then suppose this is the effective force vector. If this is effective force vector, then force into displacement, this is I want. But if this force into displacement I want, then if I have force vector as vector field, then integration of force vector dx. Same thing there, same thing here. There also, if I had velocity and then I want distance, then velocity into time is distance. So Vx dx, lower limit, higher limit. Here, if I want force into displacement, their velocity into displacement is distance. Here, force into displacement is the work done. So force into displacement, if I want, then force dx and then lower limit to higher limit will give the line integral, that is the work done. Since force, I have to calculate effective force in the direction of displacement. So force dot unit vector in the displacement direction, and then the du. If this unit vector is u, then force dot unit vector of u and du, and then integrate from lower limit to higher limit, means what distance you want this line integral to be calculated. This is our explanation. Okay, if this is our explanation, then we will file a disclosure that this is the way the line integral actually it is founded. So line integral is nothing but if I have a graph and that graph area I want to calculate so that I will achieve a target, then a way to calculate the graph area is graph integration I have to find, and then lower and higher range if I put in the direction of the area. If I want area, then I have left boundary and right boundary. That boundary I put as integration, and whatever the curve under which I want the area, I have to integrate the curve. That's it. So now if I want force into displacement, then force I have to integrate from the lower limit to higher limit for the displacement. But force has to be in direction of the displacement. So force vector dot unit vector of the displacement direction, that becomes the effective force. That force I have to integrate from the lower limit to higher limit in the distance. Then it becomes lower limit and higher limit in the distance. Then it becomes like the line integral. Now replace this force vector with the vector field. So vector field is a vector field dot product with the unit vector in the direction I want the line integral, and then du. If unit vector is direction is u, then du. If it is r, then dr. Okay, so we talked that now suppose that it is u, then unit vector is u vector divided by its magnitude. So what actually comes is u vector divided by its magnitude. Okay, and then multiplied by the magnitude. This is what we get. Now this term, so if I do like this, then if I cut it down, then it actually becomes f dot u vector. Anyway, now the idea as per this is the core concept. What I want is f vector dot product of u vector. This is what I am looking. So f vector dot product with u vector divided by its magnitude is the effective f vector along the u direction, then multiplied by the distance I am traveling. So the better way to calculate is f vector dot unit vector, that is the effective vector field that I have to integrate with du, and that integration how much distance I want along the du, that lower limit and higher limit I have to place. Okay, so this is the concept that we do for the line integral. It is crystal clear. So line integral, if I calculate through approximation, this is algebraic way. Algebraic way, we concentrate on finding the algebraic equation. So algebraic equation is f vector field f or dot unit vector along which I want the line integral. Now, if line integral, okay, so this is what also we have talked. So if line integral, line itself is a curve, line is not a kind of vector. So at each point, the vector is different on the line, and force is what the vector field is. It is also different at every moment on the line. Both are algebraically way different at any moment in the line, at any coordinate in the line. In that case, how it would be? So now the f, the vector field, now vector what we are talking about, there is a vector, vector would convert to vector field, and then this vector field dot whatever. So at any moment, suppose, so this is what generally you find, but as far as our calculation is concerned, then it is whatever vector field we get, whatever vector field we get, dot product with the unit vector what we want. So if this vector, if this line, if this is the line, and this line every moment I describe as separate vector, that then at any point, okay, algebraic equation, if we see the calculus, then we get the integration, but integration is again function of x and y. So at any point, the line equation, line vector is r, and at that moment, so suppose this point is x x0 y0. If this point is x0 y0, so what is the line vector at x0 y0? If I know that, and what is the vector that is falling here at x0 y0, so I can say if vector field is f, then f at x0 y0, f is a vector field, is a function which generates a vector. So at x0 y0, what vector it would generate? Okay, what vector it would generate? So f x0 y0, f x0 y0, so that is the vector it would generate. Now what is the line vector at that point x0 y0? If both I know, then f vector dot line vector is what I am looking at that moment. It will result in a algebraic equation. Now keep changing x and y, and then you get, so if you keep changing x and y, then you'll get the line integral from the origin. Okay, if it is in x and y, but keep changing. So at x0 y0, if I have calculated, then that is the value, instantaneous value at that moment. But if f is in function of x and y, and line is in function of vector is in x and y, then f dot line vector would result in a algebraic equation. Keep changing x and y value, give some scalar value, you will get the line integral. So that is the idea now. Okay, but what generally people they do is that if it is point is 0, and if this is the line and this point is n, then I have to divide into n part. If it is n part, then any portion. Okay, so if this line is r, if this is line is r, then this point is r0, r1, r2, r3, r4, and then rn. R0, R1, R2, R3, R4, and then Rn. If that is the case, then from R0 to R1, it is so small that I consider that it is a straight line. This is what I don't like, but this is how it is mentioned in the books. So from R0 to R1, the distance is very small. If I want to find the line integral along this distance, then whatever the force I am getting, whatever the vector field, now vector field I'll convert it to vector. So R0 vector if I vector field is a function which receives independent variable. Suppose independent variable is R0. So whatever vector I am receiving at R0, that vector multiplied by this delta R. So this delta R I will consider at delta R R0. So delta R R0 is a vector which has this magnitude and there is one vector direction. So f at R0, f at R0 dot delta R at 0 point, delta R0 vector. So f vector at R0 dot delta R0 vector. If these two vectors, if I do dot product, then I get the line integral up to this point. If I get line integral of this point, then if I keep since line integral is a value scalar, then if I keep calculating for all the sections and then add it, then I get the line integral of the full arc. If that is true, then summation of I from 0, I equal to 0 to I equal to n minus 1, and then vector field R0, then vector field R0, vector field Ri dot delta Ri. Vector field at Ri, any I dot delta Ri, and then summation of I, keep multiplying and then keep adding for I equal to 0 to I equal to n minus 1, then I get everything. So the integral form is f capital F vector field dot dr, delta R converts to dr, integration from lower limit to higher limit. This is mentioned in every book, so I have to mention it here also, where f is a vector field and r is a algebraic equation. Mind it. Okay, if r is a algebraic equation, then vector field dot dr, okay, and then integration lower limit to higher limit. So where the r is, if it is r is x and y, then we have, and vector field has x component and y component. Vector field has x component and y component. Okay, then it is f dot dx, f dx, f df, fx dx, the x component of f, fx dx plus fx dx plus fy dy, fx ds plus fy dy. These are the two components of the line integral we are getting. Then I have to integrate and then calculate the probably the magnitude or something like that. Okay, so that is the way. But anyway, now the the f, the vector field f dot dr, dr is again a vector where r can be algebraic equation. f f is a vector field, okay, that has variation along the r path. So f dot dr vector, integrate r first beginning point to end point, then you get the actual line integral. Now I have f as xi plus yj. This is the example we have taken, xi plus yj. If I have a vector xi plus yj, then I have to find the line integral of the first quadrant of the circle. Circle equation is x square plus y square equal to 1. So we want x from 0 to 1, only first quadrant. Otherwise, x spans from -1 to 1. 0 to 1, only the first quadrant, only the first quadrant. So now if I go with the actual equation, that is f vector field f dot dr vector, and then integrate lower limit to higher. Okay. Now what is r? R is nothing but x square plus y square equal to 1. X square plus y square equal to 1. Now, if I, that is fxy is kind of x square, fxy here, whatever it is. Now, I would kind of, if I want the vector form, means dr, I want dr vector in the vector form. So, dr means differentiated vector. So if it is x square plus y square equal to 1, then fxy, the actual function is y. So y equal to, okay, so y equal to square root of 1 minus x square root of 1 minus x. Okay. Now, if I see this 1 minus x square, then if I place as a, if I place it as kind of, okay, let's consider that kind of, I want this in a kind of vector form. If I have equation that is x, first there are many solutions. First solution. First solution is that I have y equal to square root of 1 minus x. So if it is true, then this is position vector. If it is true, then this is position vector. That is xi plus yj. I have vector field that is xi plus yj. Now for the circle when it is centered at origin, each point, if I take position vector of the each point, then it is xi plus y, xi plus y, xi plus yj. If that xi plus yj, if that is true, xi plus yj, then the position vector of the circle is xi plus yj, whereas the vector field xi plus yj. But if this is the vector field, if this is the vector field xi plus yj, and then position vector, then the circle, if you see the circle is perpendicular to the vector field. Vector field is xi plus yj. So if y is 0, then this is the vector field. If x is 0, then this is the vector field. If that is true, then this is the vector field. So this is perpendicular to the arc. Okay. If it is perpendicular to the arc, then I have to, if I want to calculate if I have to do the vectorization of y equal to a square root of 1 minus x square, then I will calculate the gradient. Okay. So gradient is the actual vector that is representing the circle. So now it would become xi plus a square root of 1 minus x square j. For this I have to calculate the gradient. That is actually the vector that would represent the circle when we want to do the actual line integral. So xi plus a square root of 1 minus x square j. Okay. Then I have to calculate the differentiation of it. So that will result in I minus x by a square root of 1 minus x square j. Now I have to do dot product of the vector field, that is xi plus yj. So y at this, along this line, will result in a square root of 1 minus x square j. So xi plus the square root of 1 minus x square j, and then dot product, okay, dot product with the whatever we have received, that is I minus x by square root of 1 minus x square j. Then whatever comes, then I have to calculate the integral from 0 to 1. Okay. then it would result in 0. Means x into 1 is x, and then a square root of 1 minus x square multiplied by minus x by a square root of 1 minus x square would result in minus. So x minus x is 0. So the line integral of a vector, that is xi plus yj, along the circle in the first quadrant when the limit is from 0 to 1 along x-axis is 0. Okay, so we will proceed on it. I have said that there are n number of ways that we can calculate. This is the one way that we have calculated, that we change the line equation of the circle to line equation of the tangent of the tangential vector of the circle. Okay, so that it would represent the actual the path. Then I did the dot product and it resulted in 0. We will talk 2 to 3 methods more, that how I can calculate the line integral. So this is what, so let's see what are the other methods that we can calculate the line integral. Kashmir region in India.